So am I audible to all of you students? So am I audible to all of you students?
Yes, sir.
Yes, sir, it's audible.
So did you do the numerical that we did in the last class?
Sir, that's done.
That's done. What about others? You have done it very good. So what about others? Did everyone do the numericals in the last class?
Sir, this is my first class.
Okay, you just refer to the videos.
Okay, sir.
Okay, so let us start today a different topic. Okay, so okay, did we discuss work, power, energy? That the definitions and all? Can anyone say me?
No, I think.
Okay, okay. So can you guys see my screen? Can you see my screen?
No, nothing, sir. We can see nothing.
No, sir, it's not visible.
Okay, so work, power, energy. What is work, power, and energy? So work can be defined as the transfer of energy. Okay, work can be defined as the transfer of energy. So basically, in physics, we say that work is said to be done on an object when you transfer the energy to that object. If an object transfers energy to a second object, then the first object does work on the second object. That means what? Suppose you transfer the energy to that object, then the object transfers energy to another object. Suppose someone is suppose what happens, you are a car is colliding with another car. That means what? That car, which is an object, it is transferring the energy to the other car. Okay, so if the other car is, the energy is being transferred to the other car, then what will happen? Then you can see that this first car which is hitting the other car, that means it is doing some work on that. Okay, that is how we say work is defined. Okay, and work is the application of force over a distance. So lifting a weight from the ground and putting it on a shelf is सर मैं क्लास पे हूँ हाँ सर मैं क्लास पे हूँ सर Can you all hear me? Hello.
Yes, sir.
ठीक है. Okay, thank you.
You can hear.
Okay, thank you. Okay, so so that is how work is said to be done. Now, work is the application of force over a distance. Now, I told you we discussed from the textbook in the few classes back. What is work actually? So work is application of force over a distance. Suppose you are applying some force. Suppose you are applying some force and the body is moving certain amount of distance. So then we can say that this is the work. Okay. So this is the work. So that means what? The force is applied for some distance, then you say it that the work is what? Said to be done. Now let me give you a practical example from this notes. If you can see here, suppose someone is lifting a weight from the ground. So someone is lifting a weight from the ground and it is it is being put on a what? Shelf. Okay. So if it is being put on the shelf, then what happens? The weight is being lifted from the ground and put on the shelf, right? And then what happens? Certain amount of work has been done. Okay. This means what?
Sir,
Yes, please.
hello, sir. Sir, if I lift a body from a place,
Why
then
don't you
again,
let me
if I put that as
excuse me? Let me complete it. Then you can ask the doubts, right?
yes, sir.
Let me complete
Okay,
it.
sir.
Then only you can ask my doubts, right? It will be better. Okay. I will say when to ask your doubts. Okay. Just let
Okay,
me
sir.
complete
Okay,
it.
sir.
Then you ask my doubts. Your doubts.
Okay, sir.
Work is what? First of all, you are lifting a weight from the ground and putting it on the shelf, right? So it is an example of work. Okay. Now the force is equal to what? Weight of the object and the distance is equal to height of the shelf. Now look, you are lifting it from the ground, right? So you are moving it by certain distance. Yes or not? If you are moving it by certain distance, then there is certain amount of displacement of the body. Then this is known as what? Work done. Okay. So this is what you say to be work done. Yeah, what doubt you are having? Please continue now.
Lift a body from a place, certain
Hmm.
place.
Hmm.
Then again, if I put that same, put that body in the same place,
Hmm. You are
then
not moving
still
in.
we can say, yeah, moving in another way. If I don't move any other place,
If
but
there
if I
is no
put the same
displacement,
body in the same place,
if there is no displacement, then there will be no work done. If you put the body in the same place without moving yourself, just you lift it and then put it down, then scientifically there will be no work done because there is no displacement. Overall displacement is zero, na? Got it?
yes, sir. Yes, sir, I
Hmm?
got it.
Okay. So, what is work energy principle? Look, the change of kinetic energy of an object is equal to the net work done on the object. So this is called work energy principle. Now, what is energy first of all? So energy can be defined as the capacity of doing work.
Sir,
Please mute your mics. Any problem? Someone is asking me. Any problem?
work energy problem in the work energy principle, sir.
क्या क्वेश्चन न्यूमेरिकल चाहिए तुमको?
No, no.
इसको
Suppose
कंप्लीट करने दो, फिर पूछो, ठीक है? मैं कंप्लीट कर लेता हूँ वर्क एनर्जी प्रिंसिपल का टॉपिक, समझा? हेलो, Someone please mute your mic. Someone sound is coming. उसको बोल दो ना किसका माइक ऑन है वो म्यूट करने को. Please say someone. Yeah, it's okay now. Okay. So what is work energy principle? Now the change in kinetic energy of an object is equal to what? Net work done on the object. Now kinetic energy is given by what? Half mv square. Kinetic energy is given by half mv square. Now we discussed in the previous class also the change in kinetic energy. That means if there is a change in kinetic energy, then it is equal to net work done, that is on the object. Okay. Now energy can be defined as the capacity of doing work. The simplest case of mechanical work is when object is standing still and we force it to move. The energy of a moving object is called kinetic energy. That means what? Suppose the energy that is being generated when an object is moving, then it is called kinetic energy. Now there is another form of energy which is known as potential energy. So what is the potential energy? Potential energy of an object is due to the object's position which relative to another object. That is why we have the term rho z h. H why? Because if you achieve more height, then you will have more potential energy. Okay, anyone is having some doubt? Someone is asking me for doubts that time. Tell me what doubt you have.
In sir, work energy principle.
Hmm.
According to the definition, it's a change in the kinetic energy of an
Hmm.
object is equal to the network. So if kinetic energy is in uniform motion, then according to
यूनिफॉर्म मोशन में
definition,
कैसे काइनेटिक एनर्जी चेंज नहीं होगा? क्या बोलना चाहते हो? आई एम नॉट गेटिंग यू रे. आई एम नॉट एबल टू गेट यू व्हाट यू आर सेइंग.
kinetic energy is fall in a same velocity, which means uniform. Then the network done will be zero according to the principle. Is that right or not?
Look, in uniform velocity, even if a body moves with uniform velocity, it will start from rest in certain case. Yes or no? That for uniform velocity case, the you are understanding what I'm telling you?
Yes, sir.
एक पॉइंट पे तो जीरो होगा ना.
Yes, sir.
Don't get so much excited. Okay. देखो
Sir, I'm getting excited. I'm understanding, so that's why.
ठीक है. Okay, good, very good. I want this kind of responses.
And by the way, sir, teaching
Very.
by way is nice.
समझ में नहीं आ रहा है क्या बोल रहे हैं तुम?
The way you teach, sir, it's nice. So that's why
Thank
I
you.
get excited.
Okay. You just tell me if you don't understand. That is much more important for me. If my students does not understand, then I don't feel good. You should tell me when you don't understand. ठीक है? चलो. So देखो तेमा. अभी क्या बोल रहा था कि what he was saying is in uniform velocity, if the body moves, then what will happen? So the body is moving with uniform velocity, but in certain cases you can consider that the body is in rest now. That means there will be u and v. Yes or no? Hello.
So, yes, sir.
तो u क्या होता है बोलो तो एक बार.
Initial होगा.
हाँ.
You
और
the potential energy.
नहीं पोटेंशियल नहीं, u is initial velocity.
Initial velocity.
हाँ. तो वो अगर जीरो होगा, वो जीरो होगा, लेकिन सपोज यूनिफॉर्म वेलोसिटी में अगर बॉडी मूव करेगा, मैं प्रैक्टिकल में बोलता हूँ. हाँ, but in practical field uniform velocity is not possible. Do you know why? Can you say me why?
I think increase in the attraction of gravity, speed बढ़ते जाएगा शायद.
ग्रेविटी तो नहीं होगा ना. तो रास्ते में क्या लगता है, एक गाड़ी जब घूमेगा, when a car is moving, then what force would arise between the wheel and the road? Can you say me?
Frictional force.
Very good, very good. So the car is moving, right? Huh? So frictional forces arise. So in practically uniform velocity is not possible. Yeah, that is why I said it. If it is zero, and then if it is v, then you will be having certain work done. But theoretically, if you consider that uniform velocity thing, हाँ, तब जीरो होगा वर्क डन. समझ लिया मैं क्या बोला तुमको? हेलो,
Yes, sir.
अभी समझ में
Which
आया?
means, sir,
हाँ, which means what? Say, carry on.
means मतलब from the frictional force, it may be change in the
नहीं,
motion.
फ्रिक्शनल फोर्स में अगर फ्रिक्शनल फोर्स रहेगा, हाँ, प्रैक्टिकली सोचो, गाड़ी जा रहा है,
Yes, sir.
छक्का पे तो फ्रिक्शनल फोर्स आएगा ही. तो वेलोसिटी कभी, वेलोसिटी प्रैक्टिकली कभी भी यूनिफॉर्म नहीं हो सकता है. समझ लिया? तो प्रैक्टिकली
Okay.
पूछोगे तो वर्क एनर्जी प्रिंसिपल में नेट वर्क डन जो है कभी जीरो नहीं हो सकता. समझ लिया? लेकिन
Okay.
अगर थियोरेटिकली हम लोग सोचेंगे, इफ यू थिंक थियोरेटिकली, so you can think that it can be zero sometimes when it is moving with uniform velocity case. In that case, it will be zero. Got it? Is it clear now?
Okay, sir.
Okay.
Thank you, sir. Yes, sir.
Good. Okay. What about others? Clear है सबको?
Yes, sir.
हाँ जी सर.
Okay, fine. Good. So what happens now? We go to the next topic is energy. What is energy? Although we discussed it just a few minutes back now, let me continue that thing only. So energy is defined as the capacity of doing work. The capacity of doing work is defined as the energy. So in the simplest case of mechanical work, when an object is standing still and we force to move, the energy of a moving object is called kinetic energy. That means what? Kinetic means what? Suppose a body is in motion. Nah? If a body is in motion, then we call that energy as a kinetic energy. So if a body is in motion, then we call that energy as a kinetic energy. Okay? Now, this expression for kinetic energy is half mv square. This should be here, huh? I'm sorry for that. This 2 should be here actually. This should be here. Some typing mistake. So energy is a scalar quantity and SI unit of energy is what? Joule. Okay, so this is what? The SI unit of energy. This is called joule. The potential energy of a stored energy, potential energy, it is the energy that is stored on a body, or you can say that it is the energy which is on a body by virtue of its what? Relative position. Potential energy, it is often associated with restoring forces such as spring force or gravity. The the action of stretching the spring or lifting the mass is performed by an external force which works against the force field of the potential. This work is stored in force field, which is said to be stored as potential energy. Now, just think of one thing. Have you seen the spring? Have you seen springs? You all know what is a spring, na? So now, if you put the spring, like if you press it, okay? If you press the spring, then what is happening? Then it has some energy stored in it. which is known as that potential energy, and it gets released as soon as you release that pressing of the spring. So this is the basically potential energy thing. That means what? You put some heavy object over the spring gets smaller and gets shrinked. No? So it gets shrinked. So as soon as you remove that load, then it moves back to its original position. So this is how the potential energy concept is being built. Okay. Now I'll give you another example of potential energy. Okay, so just a minute. Can you see the figure here? Hello. Can you see some figures? Hello.
No, sir, it's just notes.
Wait. Okay, then. Wait. Okay. Now can you see? This is. Let me give you an example. Can you see the figure?
Yes, sir.
So this is what. Please don't give attendances. I'm not asking anyone to give attendance, right? I hope you all maintain the dignity of the classroom. I'm not asking anyone to give the attendance. So before I ask, just don't give the attendances. Okay. So you're not here to give the attendances. This attendance won't be considered, huh? And just after I say, then only you give the attendance in the chat box. This won't be considered. Okay. So what is potential energy actually? So if you see the image here, the person is holding this bow and arrow, right? So the person is holding the bow and arrow, and this is being pulled. So this type of energy, that is being possessed is known as what? Potential energy. Okay, the bow is being pulled, so it is possessing some potential energy. But once this arrow gets moving, like once this person, I'm showing you, wait. Once this person starts moving the arrow from here, then it will be possessing kinetic energy. Initially, this is possessing certain potential energy. And this ball, this thing of the demolition machine, it possesses what? Potential energy. Because the energy is stored in this motion. That is why. Now potential energy expression is given by what? Rho G H. So if you see in the below object, okay, if you see in the below that car here, sorry, this is M, this is M, just write it as M, you don't write it as rho. Okay, this is mgh, that is equal to what? Potential energy. So m is what? Mass, g is gravitational force, and h is the height. Now look, I'm giving a practical example of this car. Suppose this car is moving like this. Now it is again reaching this top. So in the top of the hill, if the car is just stopping, it is not moving. So it will gain some height now. It will gain some height now. So this is the height. So this is the height, right? It will gain some height. So this is the height. And this height is called h, right? So if this height is called h, then this car potential energy will be given by what? M is the mass, G is the gravity, and h is the height. So G you all know, M you all know, and h is this height of this hill. So in this way the potential energy will be found out. So this is how we basically define the potential energy concept. Is it clear for everyone? The potential energy concept, is this clear for everyone? Hello? Hello? Is it clear for everyone? हेलो, ये अंशु हमेशा अटेंडेंस क्यों देता रहता है? Did I ask you to give the attendance, Imsur? You should not give the attendances, no? I'm repeatedly saying every single day that do not give attendances in the class in between. We are not here to listen to your attendances. I'm asking something you are understanding or not. So rather than that, you should give that. And I won't give any attendances if you give it in the middle. I'm telling you. So this is how potential energy is being calculated. Okay. So I hope this is clear for every one of you.
Hello, sir.
Yes, please.
And that Archer, I can understand about the potential energy, but in case of I think there is a kinetic energy is also happened, because when we that arrow moving backward, then it is also the moving energy, na?
Yes. When it is moving, it is having kinetic. That small amount of movement is there, na? Yes or
Yeah,
no?
the very small amount of movement.
The very small amount of movement is there. That means very small amount of V will be there. Yes or no? But when
Yes.
suppose you are pulling that arrow, Try to
Yes.
understand. Suppose you are pulling that arrow. Now you keep that arrow pulling.
Mm-hmm.
Do not release it. At that moment, I am saying that it is having potential. Are you getting now?
Yes, sir. Yes, sir. I can understand now.
Hmm.
But that kinetic energy will be very less.
Kinetic will be very less, but we are
Uh,
focusing on potential thing, na?
when we release that arrow,
Hmm.
then
Then
we'll
you will
have
have
that much more kinetic energy.
very good. Yes, that thing only. Huh?
Yes.
So
Okay, sir.
but when you are pulling it, huh? Then it will have
Mm.
possess some potential energy. Got it? So just
Yes,
be
sir. I got it.
clear with that. I guess it is okay for every one of you.
Yes, sir.
Okay. So then comes the term what? Power. The power means what? Power can be defined as the time rate of doing work. Power is a scalar quantity and SI unit of power is watt. Okay? So that means what? Power can be defined as what? That the work is done for certain amount of time. Yeah. So the work is done for certain amount of time. Then the what do you call it? We call it power. Okay. Now the unit of power. The unit of work done was joule, right? So the unit of power is what? Watt. That means what? So in power, what we are having actually? Power, that means what? Work done by time. That means the unit will be somewhat like that, no? For work done, it is joule, and time is what? Second. Now, if it is W by T, that means what? Wait, I'm sorry. If it is, suppose,
Sir, you can't see anything on
wait,
the screen.
have some patience. So it is what? Power is equal to what? W by T. So work done per unit time. Now the unit of work done is what? Joule. है ना? Unit of work done is what? Joule. And time is in second. So we can write it as like this, no? We can write it as like this. Joule second inverse. Yes or no? So which is called what? Watt. So this is the unit of power. So this is the unit of power. Okay. So this is how it is being done. Okay. These are the important things that you have to consider. Okay, so this is how we just define the unit of what power. Okay, so this is how power is done. So I hope this thing is clear for everyone. So if you are having some doubts, you can just ask me. So if you have any doubts, you can ask me. I don't think so you are having any doubts. Okay, someone today. Hello, hello, is someone there? Can someone respond, please? Can anyone respond? Hello, can anyone respond? I'm asking someone. Hello, 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 hello.
Yes, sir.
Okay, it's just ask your lateral friends whether they have got the PDF of the book or not. I have given in the group.
So today is my first day.
Okay, did you join that group of your class with Nishita and all?
Sir, which unit we are going? That one I confused, sir.
This is work in energy power.
Then which unit, sir? So
You're
today is
getting
my
this is
first day
work
of
energy
this.
work. This is work energy power. Okay, so I am giving I am teaching from one book also. So I am giving the PDF of the book to your friends. You just collect it from your friends. Okay.
Okay, sir. Thank you, sir.
Okay.